Hey, what's up guys, it's Akshay from AS Learning, and today in this video we will be seeing about the biggest problem with one hot encoding. One hot encoding is a technique used by almost everyone when they try to build a machine learning model because we want to convert our categorical features into numeric features, and because of this there's a big problem which gets introduced. So do you know what the problem is and what exactly is the best measure to deal with that problem? Okay, let's first see what the problem is. I'll be explaining you the problem, then later on with the help of code I'll be showing you how the problem exists, and then we'll be working on its solution, and that also we'll be seeing with the help of code. Okay, now let's first see what the problem is. Okay, so for understanding the problem, let's take one categorical feature, a very popular categorical feature named gender. Okay, so we generally have two columns in gender, male and female. So after one hot encoding transformation, we will be having two new features, gender male and gender female. So you can use one hot encoding, or you can use get dummies of pandas to get such output generation. Okay, now when you do this operation, you introduce multicollinearity into your data set. Now, how is that being happened? So let's first understand what is multicollinearity. So multicollinearity means your features which should be independent, they are not being independent. They are being dependent on each other, and one feature can be derived from another feature. And that is a big problem because having the presence of multicollinearity into your data set is not a good signs for building a model. So how does the multicollinearity gets introduced with the operation of one hot encoding? Okay, now let's say we have gender male. Okay, we know that if gender male is equal to 1, we can derive gender female from gender male, right? We know that if gender male is 1, gender female is gonna be 0, and if let's say gender male is 0, gender female is gonna be 1. There is a pattern here, there is a relationship here, and the relationship is that gender male plus gender female will always be equal to 1. That there is a presence of a linear relation being introduced, there is a presence of a collinearity being introduced, the correlation is being existed between these two features. Okay, so what can we do? To solve it? Okay, now but before discussing the solution of this problem, let's first see statistically, like how exactly is this problem being introduced. Okay, for this we'll go to the code. Okay, so here I've taken the very famous dataset.csv. I've opened my collab. This is a simple head. For simplicity purpose, I am taking here three features: sex, age, and fair. Okay, now in this, sex is a categorical feature, male and female. Okay, here I'm introducing stats model for importing variance inflation factor. Okay, now what is variance inflation factor? So VIF is used for calculating the multicollinearity. Okay, by seeing the multicollinearity scores of each of the variable, we can tell how much that feature is correlated with the other independent features. Okay, so how is this VIF calculated? So what it does internally is it tries to build a regression based model with each of the other feature independently. It calculates the R square, and then we consolidate that entire R squares in the formula of 1 upon 1 minus summation of the R square. Okay, so for more details of how variance inflation factor is calculated, I'll say you can use Google or watch any another video on YouTube. Okay, because the context is not there. The context is that VIF is gonna be telling me what is the multicollinearity score for that feature. Okay, the higher the score, the more bad it is. Okay, so here I've taken these three features, sex, age, and fair. Okay, so here for doing the one hot encoding operation, I am here using pd.getDummies method of the pandas library. Okay, now here I guess I have done the get dummies. Now after the get dummies as shown in the PPT, you will be having two new features. One is sex underscore female and sex underscore male. Okay, we have a presence of any values, so I'm currently dropping it off. Okay, and after that I am applying the variance inflation factor score calculation for each of the variable. Okay, now you can see that the VIF score, when we keep this two features, sex female and sex male, is 2.54 and 3.91. Okay, now this is an indication that these features have this much multicollinearity score with respect to age, fair. Okay, now what we'll be doing is we'll be talking about the solution, about what exactly can be done to break this linear pattern. Okay, now let's go let's go back to the PPT. Okay, so what we'll be doing is, because we can see that there's a linear relation being introduced because of the operation of one hot encoding. So what is that linear regression? So what is that linear what is that linear relation? The linear relation is that gender male plus gender female is equal to 1. Okay, now what we can do is we can drop one of the feature. If let's say we drop gender female, so will that suffice our work? Right? So if let's say someone was a female, so that will be introduced, that will be identified with 0, and if someone was a male, he will be identified with 1. So instead of two features, we can have one feature only. Okay, and if let's say if we drop one feature, will there be a drop in VIF value? If that is the case, yes, the solution is working. Right, now let's go back to our code, and what we'll be doing is, so here this was the VIF value for when we have not dropped the feature. Okay, now here I'll be dropping my thing. Okay, let me drop it here again. Okay, it is telling me not found in access. I think I'll have to rerun it again. So let's go step by step. So here we are doing the pd.getDummies. Here we have the NA values. Here we have dropped the NA values, and here we are calculating the VIF scores. Okay, now I'll be dropping here sex underscore female. Okay, now it's dropped, and now I'll be calculating the VIF score again. Okay, so what was the previous score for sex underscore female? It was 2.54, and now the score for sex underscore female is 1.44. So the VIF value has been dropped. Now because the VIF value has been dropped, it means that the multicollinearity which was existed previously has been reduced up to a certain extent. Okay, now we'll be doing this similar experiment with the embarked feature of Titanic dataset, which contains 3 classes. Okay, so here it's the same operation, and here you can see the VIF score where we had 3 classes, right? C, Q, and S. Okay, I think Q stands for Queensland, C and S I'm not currently remembering. So here you can see that S is having a very high VIF score, and so let's drop it. Okay, let's drop this feature, and then we'll be seeing the new VIF score. And here we can see that the VIF score for Q and S, like for S, for C and Q, for C and Q, there is a drop into VIF score. Okay, and we have also removed the S feature. Okay, so this is the I'll say a very popular solution to this problem, which gets introduced because of one hot encoding, and this problem itself is called as dummy variable trap. Okay, and the solution for this is that we need to reduce the number of features by 1. Okay, and we can check the VIF scores again. Okay, so if you find, okay, so before that I'll be telling you one more thing. This thing. So what happens is, if let's say if you were building a regression based model, okay, where now the equation of a regression model is in the form of y is equal to mx plus c. Okay, if let's say you have two features, if let's say consider this x as my gender. Okay, now I introduced one hot encoding, and now it got converted into two features, x1 and x2. Okay, now this was gender underscore male, and this was gender underscore female. Now because we were able to derive one feature from the another, so we can replace this x2 in this format, and we can see that the equation of line is being converted in this format. So this means that a certain error of M2 is getting introduced, which is not attached with the feature x1 at all. So it's a proof that a certain error is being introduced if one of the feature is being derived from another feature. Okay, yeah. So this is what I had in this video. If you find anything helpful, just give it a thumbs up, share it with your friends, and stay tuned to AS for more such amazing tech stuff. Take care. Peace out.